Well, thank you for joining us. My name is Eric Mabry. I'm the VP of Sales and Marketing for Interface Catheter Solutions. This is Kenny Mazzarese next to me, who is our specialist in doing tubing and balloons. And we'll be talking to you about extruded tubing for balloon production and development. So we'll talk a little bit about our core business focus so you know who the interface is, our vertical integration, what's required for doing consistent balloon forming, extrusion, balloon development, and contract manufacturing. So what we are is we're a vertically integrated provider for balloon catheter manufacturing. And by that, we do everything from extrusion to balloon development to contract manufacturing, as well as creating the balloon forming machines and ancillary equipment for balloon catheter production. We're located here in sunny Southern California in Laguna Niguel, about 20 minutes south of here. We have a little campus there, multiple buildings, and here we do have our balloon contract manufacturing, our equipment production, our extrusion, as well as our administration, sales and marketing, and the rest of the company. We've been in business since 1994, so quite experienced at this, and we've done over 2,000 different balloon designs over the years. So we're quite experienced in doing balloon design and production. And we do everything from concept to design to prototyping and then finally production. We have a dedicated team of balloon design engineers. They're forever working on new projects, so their expertise is always current. And we do everything from, we offer standard balloons to very custom balloons. And we have a materials testing lab, so we understand the material aspects of what's required for balloons. And we have our own machine shop for creating the molds necessary for doing that. It allows us fast turnaround times, plus also controlling the tight dimensional requirements that are needed. In contract manufacturing, again, we do everything in-house. We have our proprietary extrusion, which Kenny will be talking about. Basically pellets come in and balloons go out. And we probably have one of the largest fleet of balloon production machines in the market today. With our extruded balloon tubing, the key thing that we have is that we've developed tubing specifically for balloons. With that, I mean, it goes beyond the dimensional requirements to the mechanical requirements of the tubing. And as you'll see from Kenny's talk, that's one of the most critical factors for balloon production. We also offer a full range of production equipment, starting with our flagship product, which is the balloon forming machine and Parison stretcher. But we also make all the ancillary equipment for both producing balloon catheters as well as testing. So we offer swaging equipment, we offer welding, extrusion dry stretchers for like jacketing hypo tubes. And with that, we also offer testing equipment because once you've built it, you have to test it. So we have gas pressure leak testers, laser measurement systems. And in fact, one of the things we're showing at our booth today is a balloon visual inspection system, which will do both dimensional and visual inspection of your balloon. So we've kind of taken in visual inspection to the next level. And with that, I'm going to hand it over to Kenny.
Hello. And so what makes us vertical integrated when it comes to balloon design and development is we work really close with our customers and we build a partnership. And what we do is we work with their engineers, our engineers working with their engineers to going through the quoting, requirement, inspection, alignment, and design input. And then we get into the extrusion, balloon, and tooling design. Go through all of the fabrication processes, prototypes, go through design review, verification, and then production transfer. And so one thing that makes us unique is that we do work with the customer. So we don't force you to use our inspection processes. We don't force you to use our performance criteria. We actually work with you and develop the process around your needs. And so when it comes to balloon consistency, we've been doing balloons for quite some time now. And as you guys know, if you're into balloons, that when it comes down to trying to troubleshoot some sort of flaw, it always seems that there's way too many variables to actually pin down where the problem came from. And so the four basic aspects to balloon consistency is temperature, pressure, expansion, and stretch. And you have to be able to dig deep into all 4 of these and be able to find the variables and make them constants. So one aspect is the expansion. One mistake that's made is that you're going to use a 3.5 millimeter balloon tube to make 4 millimeter balloon or a 3 millimeter balloon and wonder why your compliance characteristics, your bursts, or your shrinkage is different. So controlling the expansion ratio is one of the key. And then the stretch, you have your longitudinal stretch, which you have your wall reduction factor of a balloon. That's it goes from the wall thickness of your tube to the wall thickness of your balloon. And that's actually a factor of your expansion and your longitudinal stretch. So if your expansion ratio is not consistent, then you're going to have to alter your stretch distances to achieve that wall thickness that you're looking for. So by controlling the expansion ratio and also controlling the percent or the elongation of the extrusion at where the balloon blows during its primary is key. And then what's going to end up happening is, if you guys have done balloon blowing, you're going to find out that you always have that wonder why you put a balloon on the machine 2 weeks ago and then you put it on with a different balloon tube lot and figure that you have to use different temperature, you have to use different stretch parameters, and then you find out that you get fish eyes and diamonds or radial bursts or something of that sort. So being able to control the expansion, the stretch, the material properties is going to help you control the temperature for forming and heat setting. And then with that comes your pressure, which are your balloon forming parameters. So once you're able to control and keep everything, take all of your variables to constants, you're going to get consistency and repeatability. And your setup times are going to drastically reduce from the horrible 1 day trying to set up that 2x40 to a quick turn to where it's only a couple of hours to verify. And some of the balloon defects that are related to these variables, especially in the extrusion, are you've got crow's feet on the top left, which is just a material buildup in the cone, which will affect your folding profile and your IDs and ODs of your balloon. And then the tears. What happens there is that you have balloon forming parameters that you set when you develop the balloon, and then the next lot of tubing comes in and you find that you're getting tears on the tails, which is causing radial bursts or tearing during your bonding process. And this is directly related to the elongation of your extrusion. And then your fish eyes can be from your expansion ratios being off, you're stretching too much, temperature's too low. So that's why it's very important to understand where your variables are at and controlling those variables to be able to sit down with your team when you see fish eyes and be able to identify where the problem came from. And then strain lines are going to be the opposite effect of your crow's feet. In fact, your strain lines are your strain lines are going to end up turning into tears if you decide to pull too much. And I don't know. And so these strain lines here are going to end up turning up to be like these tears. And then with the tears and strain lines come your radial bursts. So you've got really thin cones. Your strain lines are telling you that you're overstretching the material. So you're destroying the molecular orientation of the material in that area, which is going to cause radial bursts. Okay? And so what we had to do to control the variable of the extrusion is we had to develop our own extrusion process that revolves only around balloons. And so you have to be able to control and monitor the process. And we have inline processing, inline inspection to where the concentricity has to be within 90%. We have elongation that's specified on multiple points of the curve, so we can actually control the slope of the tensile characteristics, and making sure that the mechanical properties of the extrusion are consistent throughout the entire lot, and more importantly, the next lot is just like the one before. This is just some examples that we've run into. You could see that if you were this is the ultimate percent strain on this particular tube, and these tubes are all the same dimensions. So if I was to develop a tube with this one, or develop a balloon with this tubing here, I am going to end up achieving the ID-OD combination I'm looking for and keeping the profile low. And then the next lot, I use this one here, and I find out that I end up with tears, strain lines, and radial bursts because the tubing doesn't have the necessary strain for my secondary operations. And these are just some pictures of what we call fisheyes, which are tears, the separation of film. And this here, we sent this fisheye out. It's 5,000 times magnification on an SEM, and you've got 20 micron line here. So this is just showing why fisheyes are one of your most detrimental flaws when it comes to balloon burst, performance, fatigue. Okay. And these fisheyes, like I say, are sometimes very hard to figure out where they came from unless you're able to control your variables. Okay. In our extrusion process, we control every aspect. We want to know what the temperature is in the water bath in multiple locations. We want to know what the temperature in the room is. We monitor and track everything that we do when it comes to our extrusion. And more importantly, when we develop a tube, we want everything to be fully integrated with the program, so I am able to upload that program without having to turn any knobs or have to rely on someone trying to interpret some of the parameters. And this year, what we've had to do is, we've also seen in the past to where we would blow a balloon, the balloon dimensions are all exactly the same, but we would find out that some of the burst pressures are different. Sometimes it's 3 atmosphere low on this lot, sometimes it's higher on this lot, and don't understand why. So what we had to dig into that, and we find out that the stress of the material varies with each extrusion lot. And the stress levels can be lowered due to excessive shear force, drawdown, the way that you're cooling it, your haul-off speed, just a variety of issues. And to ask a vendor to be able to control all that was very hard to do, almost impossible. And so what the process that we developed is we tested it on a molecular level to make sure that we weren't damaging the material at the molecular level. So we sent it out, and we did our molecular weight distribution and our GPC with blended material, the raw resin itself, and then extruded all 3 of them and found that all 3 of those are that we're not damaging that with the excessive shear forces. And so with that, we're able to, so we also do balloon development. We've got custom balloon designs, a wide variety of shapes. If it's a balloon that can actually be cut into a mold, we can blow a balloon out of it. Okay, and this here is showing through polarized lighting. You've got the orientation going through, you got incorrect orientation on the left and then the optimal orientation on the right. And this is an exaggeration, but you could see that why it's so important that every balloon diameter has its own unique balloon tubing size. Because if it doesn't, your whole family of balloons are going to have different performance characteristics. Your 2 millimeter might have a compliance of less than 5 between nominal and RBP, and then your 10 millimeter might be 12, 13% because your expansion ratios and longitudinal stretch are not constant. And so also, to be able to track what we do in our balloon production and our balloon development, we do a sampling size of all of the critical and non-critical parameters, so we can always, or dimensions, I'm sorry, and so we can always go back and find out what was wrong. So just keeping a log and keeping track of absolutely everything based on, we use an AQL 1.0 C=0 sampling size. It helps us to be able to go back, identify, and troubleshoot any problems that may occur. And this here is showing this particular balloon has special instructions that we adopted from the customer and put into our process. We do sampling sizes based on the AQL 1.0 C=0 on all critical and non-critical dimensions. And we also do burst and fatigue and capture the MBS average and standard deviation. Okay, and during our contract, during the manufacturing of the balloon, we take the customer's tolerances and we put our own internal limits on it to be able to control and monitor any kind of drift in the positive or negative direction on all dimensions. Okay. And so, like I said, we are a balloon contract manufacturing, balloon development professionals who developed balloon extrusion specifically made for balloons. So. So if you guys have any questions in regards to extrusion or balloons, feel free to stop me, pull me aside, or come over to booth 2301, and I'll be glad to talk with you guys. Does anybody have any particular questions? No? All right, feel free to pull me aside. Thank you.